Okay, well, so this is day 33 of doing Leetcode daily until I get a job. So let's start with the questions. Okay, so we are just continuing our problems here. Consecutively, we are doing first 50. These two are remaining, and then these two are the next ones. We will try to do these four questions. Fine. Let's go to our first question. Yeah, so that's basically an easy problem, we can say. Um, that we are given with n by n matrix. So see, we have to rotate this matrix 90-degree to this. So how we can do this is, firstly, let's if we can find the transpose of this matrix, means row converted to column and column converted to row. And after that, if we swap the corresponding columns, like first column with the last column, second last with the second column, third last with the third column, and if there are no odd number of column, the middle column will stay as it is. So let me just show you how this will work. If we just say it's a n by n matrix. Okay, so this is n here. So for int I0 to I less than n I plus plus, and for int j0 to j less than n j plus plus. I will also try to speak as less as possible because currently, like, I'm not in a mood of explaining things. I will just try to explain wherever I feel that I should. Okay, so this is basically the transpose of it. After this transpose, we just need to do what is swap the corresponding columns from first and last. Okay, so for int I0. First row we will take, ith row we will take, and the left element with the right element. Fine, and left, yeah, I guess that's it. Is less than I0 to I less than n. Wait. Uh, if we try to print this, have we done the right transpose? 1, 2, 3, 4, 5, 6, 7, 9. Yeah, it's basically the same. It's not transposing. So the problem is with here, the transpose. So what we can do here is I0 to it is basically staying 1, 1 is staying same place. When we reach at 0, 1, 2, 0, 1 with 4 1, it should be replacing it, but when we go again to 4 it will again replace. So yeah, it's basically cancelling out the effect. So how can we make it right is if let's try this. Yeah, this should work. um, Obviously, yeah, yeah, that worked fine. Earlier what was happening that when we reach at this 2 will be replaced by 4. 4 is here, now 2 is here. But again, after iterating this first row, we reach the second row. When we reach again here 2, then 2 is again replaced by 4, 4 by 2, so it will be the same again, so no difference. Okay, so this is what was happening, and we avoided this. So this will work perfect. Perfect. So let's now go to the second question, that is power of x, and obviously we are not going to do the direct inbuilt function. What we can do instead of that is we have to raise x to the power n. So we have to raise x, basically x multiplied by x n times. Perfect. This is what we need to do. So how we can do this is, yeah, perfect. Yeah. So how we can do this, how we can achieve this thing is that if we x to the power n, we need to do, fine, x times of x. If x square is there, then it should be x multiplied by x. But if x raised to power 4 is there, then it should be x multiplied by x and then n by 2. Right, we can call a recursive function here. Yeah, that can be pretty easy. Yeah, so we can make it like um, helper. If we say double x and n, then if n is equal to 1, we'll just, if n is 0, firstly we'll return 1. If n is n is less than 0, yeah, if n is less than 0, we will return what, helper with 1 by x and then, correct, and minus n, sorry, we'll make it positive then. Yeah, otherwise uh, if n is even, if n is even, then we will return x multiplied by x, and power will be half now. Okay, but what if it is odd, means like at last the power will be remaining 1, like, right? So if x raised to power 5 is there, x raised to power 4 is there, then what it will be, x square square. Then we will do this power 1, so 1 will be obviously at the last, what will be remaining, right? So whenever it's odd, then what we can do is we can multiply x here to the helper function, and inside we can obviously do x multiplied by x, and this will be n minus 1 by 2. Yeah, that should work, and we will just return helper xn. Perfect. Not a really tough one, but yeah, good. Wait, 1 by x cannot be done here like this. Double and x, x is this and is this. Okay, 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 okay. So this is an integer, but if we make it positive, it crosses int max somehow. Yeah, because it's -1 up to here. So instead of int, we can take a long here. Then it should do. Yeah, perfect. Again, easy one. Not like not. I will not say easy, but uh, understandable. Like quite fine. Next is n queens famous problem that on a n by n board we are given n queens and we have to find position for each queen where they will not attack each other, like safe positions for all the n queens on a n by n board. Obviously on a 2 by 2 board it's not possible to uh, put them. Even in a 3 by 3 board it is possible. In a 3 by 3 board it's possible, obviously. Yeah. So uh, so basically, see, what we have to do in this question is we have a board. Okay, just like the Sudoku question, we just need to find the safe positions. Okay, we put one queen, then before putting the another queen, we will try to find the safe position. And if it doesn't let us, then we will backtrack for the first queen also. Okay, so this is a normal backtracking question, famous backtracking question, not normal but quite good question, but it will work same way as the Sudoku. In the Sudoku, what we were checking is that in the row, in the column, and in the smaller box, there should not be the same number. Similarly, for a queen in the row, in the column, and also diagonally, there should not be any other queen already placed. Correct. So what we can do here is we can go row wise. We'll go row wise. Okay. Firstly, we'll go for this row. We'll put a queen. Well, for this row, we'll put a queen. For this row, we'll put a queen. Similarly, okay, in every row there should be one queen, in every column also there should be one queen. So obviously for each row we are already putting one queen, we know that. Okay, for the row we will run the loop only one time, so only one queen is put up there. But what we need to check now is that in that column also there should be only one queen. So if we put the queen here, now we start checking from here. Okay, if we start checking from here, its column should not have. Second thing, see, whenever we put any queen, we know that we know for sure that if we wait, yeah, if I can remove this. Okay, fine. So if we put a queen here, let's just say, okay, now we will go to the next row. Okay, and obviously not this column to the next column. We cannot put in this column. Okay, we will add a column. Now we will check for this column. If we put a queen here, what are the possible directions we need to check? Just think about this, that obviously we do not need to check this row. Obviously we don't need to check, we only need to check this column plus the diagonals. Basically, whatever is left side of this line, whatever is left side of this line we need to check. For this position, what's left of this diagonal, this diagonal, and this column, means the vertical column, the lower left, and the upper left diagonal. These only things we need to check. We don't need to check these directions because we haven't reached those directions yet. Correct. So that's how we need to do. That's how we need to go. Okay, this is obviously not possible to put here. Now I'll put here. Okay, it's safe now. Now we will go to next row. Okay, after this, and this is done. Okay, after this we will go to next row and this column. Is it possible? Again we will check this, this and this. No, it's not possible. We can put here. Perfectly fine. Now we will backtrack up to here. Okay, up to here we will backtrack. Now for this column, can we put it here? Okay, now we will check to the left, to the right, and to this column. Nothing is here. Perfectly fine. Now we will check plus one column of this. No, we cannot put it here. Plus one column of this. Yeah, we can put it here. So this is how like we need to go, and it will give us all the possible cases. Not to worry about, because it's basically checking all the possibilities and backtracking for the rest of the remaining of the possibilities. Okay, so simple backtracking thing, and what we can do here is uh, let's start with making 2D vector of string, which will be our answer. Fine. And let's form a board basically of strings. You can say board which will have n rows. So n rows and n columns. A string will have n size, and initially everybody is a dot, means empty positions. Fine. So we formed an empty board now, and we will call the helper function for us, and we are going row wise. So we will start from basically we are going column wise, first column, second column, third column, like this. So we will have a board there. Okay, answer there, initial column what we are call starting with 0 and n, and we will return the answer. Fine. Now void helper will be the board vector string, and board void will be the answer vector vector of string answer, and end column and n. Whenever the column becomes equal to n, we will just push back the string here, push back board here, a possible answer, and we will return. Fine. Otherwise what we will do is we will go to each of the row, let's say row starting from 0 to n, and our column is obviously C currently. So if we will check if this position is safe. If it is safe, we'll send the board row and column and n. If this is safe, this is checked that this position is good, then we will check for the further positions. Means we will put a queen here, let's say this, and we'll call the function again helper with the board answer, next column, and n. Okay, yeah, and then we'll backtrack. We will again put a dot here. Perfect. Now let's write the check function. For check function we already discussed about this. We need to check the vertical column plus the upper left and the lower left side of this current index. So bool check function vector of string and board int r, int c, and n. Fine. we'll do here is we'll go to for the first column of it. So int I 0 to I less than this column only. We will check I plus plus that that if board for this row and all the columns of it, basically if there is something, if for sorry, for this row will be same, we'll go to different columns. Okay, okay, we need to check here, right? Column is already 1 plus there. If we see here, column we have already incremented by 1, so column won't be never be the same. If this column is same, we have already moved to c plus 1. We need to check the row now only. Okay, so this was wrong, this one, and this and this, these two things we need, these three things we need to check. Okay, so first is this, uh, if Ri is a queen, then we will return false. Fine. And the rest of the two conditions are uh, how to check the upper left diagonal is that we will start from the row and column. Fine. We are decreasing the row, decreasing the column, both, right? So I must be greater equal to 0, and then j must be greater equal to 0, and 0, and I minus minus, j minus minus. Yeah, I think this should work. And if board I j is equal to a queen, we will return false again. For the lower left, we can say, for the lower left we're increasing the row numbers, so I must be less than n, and j must be greater or equal to 0. Yeah, and I is incrementing, means row is incrementing. Perfect. And if nothing happens, we'll just return true. Yeah, I think this should do the thing. Mm-mm-mm. Okay, it should be a character or a string. Okay, we cannot compare this then. No. See, vector, but board is a vector only, right? Board is a vector only, and board R I should be a character only. Board is a vector only. As a character, then it should work fine, I think. Okay. This is wrong. Yeah, that's fine now. Yeah, obviously this will work good, and perfect. And queens 2 must have a small modification, and problem response is not to number of distinct, basically the number of distinct count we need to return here. So let me see the video. Yeah, that's good. Okay, so count we need to return, right? Then what we can do is uh, let's copy this, because it's almost the same question. Here we are finding all the possible answer, the vector of it, and here we need to return just the count of it. So it's like almost the same. Let's see how we can modify this to get uh, discount. What we can do here is, okay, uh, if we can do one thing, let it make integer. Okay, and if whenever it's we got a solution, instead of pushing it, and let's not take an answer really. Okay, and let's return just as it is, helper out of it, remove the board, remove this answer, and instead of this we will return 1. Fine. And rest, when the count will be incremented is at this time when we got a queen, and now next queen will be doing. So we can say, uh, if we take uh, counter here, every time we are calling this, let's do this. Fine. Answer to be removed from here, and return the counter here. I guess counter here. Okay, it will return 1 when we reach the last, that it is one of the solutions, and any other solutions in this functional call will return us any answer which will it have. So yeah, this should be fine. Return answer, no return not answer. Basically we can remove this. Fine. Yeah. Yeah. I mean, it was not of a problem. Like, we can also even do in this case also. We can return answer dot size. This will work just fine. If we submit this, we will also try that. Yeah, perfect. So yeah, we can also do this, that if we copy this whole and paste it here, and do this, it will obviously won't be a optimized timing, like time complexity, but answer is a vector of strings. So how was it that it's basically this one string, two string, three string. So vector 0 dot size, no, it's basically answer dot size. Yeah, answer dot size. So if we run this and try to submit this, it will also work, and but it's not uh, from the, I was like thinking about the time complexity, that it will not be a good one for this, but it's beating 100%. Like, how the hell? Uh, I mean, not much difference in it. It was just that we are pushing in it. We are just return. We have to just return the integer there, but we are taking extra space here, a lot of space, because if we this has 9.06 MB, and if we check our last submission, it had 8.28 MB. Yeah, but time is better in this case. So I mean, it's strange. We don't know how this thing happens, but somehow it does. Perfect. So we can see that on the first page we have done all the 50 questions. Nothing is remaining. That's a good one for us. And plus our 160 questions are completed. Good one, I can say. Fine. So that's it for this video, I guess. Yeah, that's it. We will do other questions in the next video. So that's it, guys.